Hello friends, welcome back. In this video, I'm going to show you how we can deploy Spring Boot application and MySQL database on Kubernetes cluster. Let us look at the agenda. First, I'm going to show you how we can create Kubernetes objects for Spring Boot and MySQL database. And we should know what is persistent volume and persistent volume client because we are dealing with database. I will show you later how to run Kubernetes cluster on laptop with Minikube. Later we dockerize the Spring Boot application, and later we pull the MySQL image from Docker Hub, and we can make it available on our Docker registry inside the Kubernetes cluster. And finally, we look at how to deploy Spring Boot and MySQL with the Kubernetes objects. Before getting into the demo, if you haven't subscribed to my channel, subscribe and press the bell icon so that you don't miss my future videos. Creating Kubernetes objects. Now we have a look at what are the Kubernetes objects, which are basically YAML files. For our Spring Boot application, we need deployment YAML file, and MySQL needs ConfigMap, secrets for admin and secrets for user, and deployment YAML file. So what are these objects with respect to Kubernetes? What content they have? For example, when it comes to deployment YAML file, it describes about the desired state of your application after deployment. So basically you define whatever you required for your application, especially like what is the application name, what is the image name and version, so what is the location where it is located in a Docker registry. So everything you mention in a declarative format, so that once you deploy this YAML file, Kubernetes fetch the application image and it will deploy on Kubernetes cluster in one of the nodes. Next, the service. Service is nothing but an abstraction to an application. In simple terms, if you don't define service object for your application in Kubernetes, you cannot access it from outside. So basically exposing your application to outer world. And ConfigMap. ConfigMap contains the environment details, non-sensitive information like a database name and what is the host name where this database is running, for example. So it basically contains non-sensitive information. The next one is secrets. Secrets and ConfigMap both are same, but secret YAML file contains the sensitive information like passwords and username, and so the whole Kubernetes cluster goes down. In that way, we can make storage highly available and reliable. So you can configure all this kind of storage using persistent volume. It is like a cluster resource, just like a RAM and CPU. Kubernetes provides an interface for persistent volume storage. As a developer, we can use the interface to connect the actual storage with persistence volume. The persistence volume will be defined in our deployment YAML file like this. Name MySQL persistence storage. This is the name of the persistence storage, and we are requesting on this specific path. The data should be stored on this path, and volumes name, the name of the persistent storage, and persistence volume client. So what is persistent volume client? Kubernetes just provides the interface for your persistent volume storage. As a developer, we should know, we should define what capacity that we need on storage and access modes, read, write ones. So you can see the example here. So this is the persistent volume client, which we can define as a kind in our deployment YAML file, and metadata information. This is the name of the MySQL PV client. So in this way, we can define the persistent volume client. Persistent volume client, nothing but a request from the user to the Kubernetes cluster. Now let's get started into the actual demo. You are seeing my IntelliJ IDE screen. Here I have a very simple Spring Boot application, that is a students app. This Spring Boot application uses MySQL database to insert the students information and retrieve the students information whenever we want. So it contains very simple classes like as usual controller, which will have some endpoints to retrieve and update the students information in the MySQL database. So it calls the students repository, and we have the entity student entity class that contains ID, name, course, and grade. So This information will be pushed to MySQL database and also retrieved using this application by calling REST API of the Spring Boot. And we have the student repository interface, the main application. So it's very simple. Now we look at how we can create Kubernetes objects that are required to deploy this application and also the MySQL database on Kubernetes cluster. So we can create a directory inside the project called Kubernetes. So we are going to create our required YAML files in this folder. Let us create MySQL ConfigMap. ConfigMap contains the information like API version, v1, kind, what kind of object it is, it's a config map, and metadata. So what is the reference of this particular config map? So we have to give the reference of this config map in our deployment config, deployment YAML file. I will explain about it later. db config, we can name it as a db config, and data, it's about our MySQL database details, like what is the host name. So we can name it as MySQL, and name of the database we can give a, so let us put it as test. So this is the config map for MySQL. Now create the secrets. Let's name this file as MySQL admin secrets. So this file contains the root password for a MySQL database and its password, so that our application access the MySQL database. Let me copy the content of config map because it looks like almost same. So we need to mention it as a secret, and we can name it as db admin, and we don't have host, not required, but we have to mention the password. Password is actually admin123. So we should not mention the password in plain text. We need to encode it when you are putting into Kubernetes. So for that we have a command and paste it instead of plain text. And next we have to create the secrets for user, MySQL user. So we name this file as MySQL user secrets. Yeah. Let's copy the same thing, secret, and we mention it as db user, and we need username and password for our database. So this username is test user, and password is test user at 123. As I said earlier, we should not mention secrets in plain text, so we need to encode it. Let us encode this plain text into secrets into our deployment YAML file. I will show you how we have to refer these secrets in deployment. Okay. Let's create MySQL deployment YAML file. MySQL deployment YAML. It's a huge file actually, so I have already have this content what to be there. I just copy for I already have the content of this file. Let me copy from my source. I copied it from my source. So this file contains the service, As I told earlier, service is an object in Kubernetes cluster so that you can expose your application to the outer world. So if you don't have service here for your application, you cannot access it from another node or from your laptop as well. Yes. So this contains the service. Version is v1, metadata MySQL, and app name also MySQL. It's a tier, it's a database tier, and the spec, the ports and which port it is running on. 3306 is a default port, and target port as well, 3306, and selector app MySQL and tier database and cluster IP none, and data. It will have the persistent volume client. I already told you what is persistent volume. We already discussed a few minutes back what is persistent volume claim, and metadata will contain the name of the persistent volume claim, and application is MySQL and tier is database, and access modes. So what you want to do with your database, you want to read write in the permission to the database. So we mention it as read write once. Resources and storage, we need 1 gigabyte. So we need 1 gigabytes of storage in our database. So we are claiming as a user to the Kubernetes cluster, please provide the required persistent volume for this application. So we are requesting to Kubernetes cluster. So once you define this persistent volume client your YAML file, especially in a deployment YAML file, so that Kubernetes will take it off dynamically based on this request, and it will create the volume for our database. And next, deployment. So deployment configurations for our MySQL database. Name will be MySQL and tier database as useful, and the specification. So labels MySQL tier database recreate. So whenever the container goes down and crashes, so we have to create, Kubernetes will create the new part for this, so recreate the entire database. That's what it means, the strategy. And this must match the service and deployment selected. So in the service, you have mentioned MySQL and tier is database. So whatever you mention in a deployment, so this should match with these details, these labels. Otherwise, it cannot recognize. And the specification and the MySQL image name and its version, so that whenever you mention this image name and version, Kubernetes will try to retrieve this image from the Docker registry or in your private registry, and it will try to deploy this in a container. So this is in a workaround for the popular issue with MySQL database. Whenever you are trying to deploy MySQL database, if there is already old MySQL data information then it cannot deploy it, so it throws some error. So it's a workaround, just ignore that, that's not important for now. And name of the database is MySQL root password. So we have given the reference, that's what I told you. If you see MySQL admin secrets, this is the reference name for this. So this both value should match, otherwise it cannot fetch the required password. So the password is key, the key is password that is given here. So this is the key. So it gets this value and it applies in the deployment, so that the required credentials will be applied on the MySQL database. MySQL user and secret, so DB user. The key name is DB user and key is username, which we have defined it here in secrets. Username and password, the name is named DB user, and secrets like username and password that you can see here. Username for username DB user and secret key and password, so that the application will have the required credential to access the database. dbconfig. This is the global config of MySQL database, which we have defined in ConfigMap. So it will know the host name and the database name. So if you provide all this information about MySQL in deployment YAML file, Spring Boot application knows each and everything about MySQL database, how to access it, and on which port it is running, what is the admin password, and what are the required user credentials to access the data. And volume mounts. My persistent volume storage. It's a name that we can name it anything. And mount path. We are requesting Kubernetes. The mount path should be here under the var lib and MySQL. So whatever the data that we are storing to MySQL database, that will be stored under this path. Volumes. So this is the same name as this, and persistent volume client, the client name that we have defined here. It should match with this name. Yeah. As I said earlier, the volume mounts, it's a physical storage, it's not within the Kubernetes cluster, the more persistent volume, because out of the box, because Kubernetes doesn't provide persistent volume out of the box for us. So as a developer, we have to request it, how it should be mounted on external storage or the storage inside the Kubernetes. Basically, we don't. So this volume will be available even though Kubernetes cluster crashes. So as a developer, we should manage it. That's all about MySQL deployment. Now let us create our application deployment YAML file. I already have the content of this file. Let me copy that. So the Spring Boot application deployment YAML file contains this information, the kind, the service, as I said, what the service means, the API version, metadata, name of the application, students app, then label also students app, the ports. So node port is 30163, so we can access this application on this port once our application is deployed and successfully running. So 8080, it's an internal Tomcat port. We will redirect to the node port 30163, so we can access our application via this 30163 only, not on 8080. Target port also 8080. It's selector, students app, node port. So this is node port, and deployment information will be like name, students app, and match labels. So this label should match with application name. And replicas, we want 3 replicas that should be running, so we'll be seeing 3 pods running for this application. Students app, labels, and containers. So we have to give the image name and its version, so that Kubernetes cluster pull this image from Docker registry and it will deploy on one of the nodes. Container port 8080, DB host. So we have to give database information here to our application so that it can get the information about MySQL database. So for this, we have to give the reference of our database that we have defined in the MySQL ConfigMap. This is the reference name for this. That's what I mentioned here. And the key is host. The host name, the key. It will fetch this information from here. Host name is MySQL, name is the test. That's what it is trying to Get it? So db config name, username, db user information. So this information will be fetched from MySQL user secrets YAML file, and password also as same. So I think these are the files that are required for our Spring Boot and MySQL database, and we have to go ahead with deployment. How we can deploy these files? So we need to use kubectl CLI tool. Of course, you know what it is and how to install it. If you don't know, I will provide the link how you can install kubectl on your laptop. Go through the document and you can install it. Now we have all required YAML files for the deployment of our Spring Boot and MySQL into Kubernetes cluster. And let's create the Docker image for our application. Before deploying MySQL deployment objects, we need to make sure that the MySQL image is available in our Kubernetes cluster Docker registry. So for that, we need to pull it. So to pull the Docker MySQL Docker image from Docker Hub, we have to run pull command. Before that, we need to make sure that our our CLI tool is linked with the Kubernetes cluster. For that, we need to make sure that by using this command eval minikube docker environment. So then if you run docker images, so these are the images that are available in our Kubernetes cluster. So we know now we have MySQL 5.7, MySQL 5. Latest. So I already pulled this image, but I want to show you how you can pull it if you don't have, because by default Minikube doesn't have MySQL image in its Docker registry, that you have to pull it. So docker pull MySQL, you can give the version. Let me give 5.6. It takes a couple of minutes to download the image. So in this way you can download the Docker image of MySQL from Docker public registry, that is Docker Hub. So once it is available on your Kubernetes Docker registry, then you can deploy the Docker image using your deployment objects. Once this process finishes, then you can see the 5.6 version on your Docker registry. So we can create the Docker image. Docker, first of all, we need to run our Minikube so that we can have the running Kubernetes cluster. So how to start Minikube? Start. If you don't know how to install the Minikube, I will provide the links in the description section. You can go through that and you can install Minikube on your laptop so that you can run successfully Kubernetes cluster, so that you can experiment by deploying any application on Kubernetes cluster. It's very simple thing, so you don't need to worry about that. Or you can find a lot of videos on YouTube how to do that. So it takes a couple of seconds to get it run, because if you build a Docker image, so this Docker image is going to register in a Docker registry of Kubernetes cluster, which is running in our Minikube. Otherwise, if you build the Docker image before running that Minikube, the Docker image will be stored in your local laptop's Docker registry. That's the reason I want to run the Minikube first, and I want to link our commands, whatever it is saying. So using this command, we can link, or whatever the Docker images that we are building will be stored in our Docker registry of Kubernetes cluster. So now we have linked our CLI tool with, so we have these applications in our Docker registry of Kubernetes cluster. Now we are going to build the Docker image for our application, Docker build, and I already built this before. So let's mention the version as 4.0 so that we can, first of all, we have to run the maven clean install, so that because there is no jar file, so first we need to build the jar, then we can build the Docker image. Otherwise, now we'll have the Docker image that is registered. We push it to our Docker registry inside the Kubernetes cluster to see that the Docker images. Now you can see the 4.0 version in our Docker registry. Now we have this one, and also we need to change students deployment. We have mentioned it as 3.0, so it must be changed to 4 so that it will fetch the 4.0 version and it will be deployed in Kubernetes cluster. Now we are on the base directory of our students app application. Now we need to go inside the Kubernetes folder. Now we are here and we can see let us deploy MySQL ConfigMap first. kubectl apply MySQL ConfigMap created. Next we'll deploy admin secrets YAML file created. Then user secrets created. You can see what are created under get deployments. We don't have, you can see secrets. Since we didn't deploy any deployments, we have deployed secrets. You can see that db admin db user, this is the default token CMV2 version. It is the default secrets of Kubernetes clusters. So, and now we have deployed secrets and ConfigMap, and you can see ConfigMap details dbconfig. Yes, and now we deploy the deployment YAML file. Now kubectl apply MySQL deployment YAML file. You can see that service is created and persistent volume claim also created for us, and deployment. Let's see what it is. kubectl get services. Yeah, MySQL service is created. It's running. That is on 3306. The Kubernetes service is the default one, and kubectl get pods. Yeah, pod is created for MySQL. So this pod is running, and we need to deploy the student deployment YAML file. kubectl apply student. Yes, service and deployment has been created for students application. Let's run kubectl get pods. Yes, the MySQL pod is running, and 3 replicas for students app is running because we mentioned that we need 3 replicas of students app in our students deployment file. That is here. So if you give 4, it will deploy the 4 pods for you. Okay, so application is running. Let us try whether we can create the data and we can access the data using REST API of this application, which is running on 3330163. Yes. I have installed the Boomerang REST client on my browser. It's an extension from Chrome Web Store. You can install it on your Chrome browser as well, so that we can test any REST API by sending requests from our REST client. So we need to know on which IP address our Spring Boot application is running, and the port. The port we know already from here, but sometimes we don't know on which IP address we know. That's for that. Sometimes we don't know on which IP address our application is running. To know that, you need to run kubectl cluster info. Sorry. So actually, this is the IP address that we need to use to make a call to our REST client, to call to our REST API. So it is running on 30163. Correct? Yeah, 30163, and we have the REST endpoint. Go to the controller class, and you can see the REST endpoints. So let's see students. So we got the empty response, and let's try to insert some data. Add student, and we have to use the post request. So we have just 3 attributes: name, like Raju, course, and CA, grade, plus. So we are trying to insert this data into our database. Post request, student added successfully 1. So this is the ID. Actually, the ID will be generated automatically by our Spring Boot application, and also we can add one more, like Kumar B. So another ID is created. Let us try to retrieve this data. Yes, this is the data that we have inserted. Minikube also provides a beautiful dashboard for our Kubernetes cluster. To see the dashboard of our Kubernetes cluster, you can run the command Minikube dashboard. So it will take you to the Chrome browser, and it will show you all the cluster information. So you can have the complete overview of your Kubernetes cluster. See, if it is showing green, all the pods and deployments and replica sets all are healthy, so all are working fine. There is no any issue. If something shows like red or something, so it means the pod is not running or something. Yeah, you can see how many nodes are there, namespaces, storage classes. Yeah, we have created storage class, standard storage class, and pods. And we can see persistent volume climbs as well. So as part of our application, we have created persistent volume, and the persistent volume climb request is here, and secrets. Yeah, it's a very beautiful dashboard, really useful to monitor your Kubernetes cluster. So this is how you can deploy Spring Boot and MySQL applications on Kubernetes cluster. That's it, guys. Hope you liked this video and you have learned something new. And if you like this video, please like it and share with your friends and colleagues so that they can learn. And as usual, I would like to request you to subscribe to my channel and press the bell icon to get the regular update from my future videos.